Good evening, everyone. Welcome to the final session of our second week. Yesterday, we navigated the digital world of cyber forensics. Today, we return to the chemistry of crime. We are diving into forensic toxicology, the science of poisons, drugs, and chemical analysis. To guide us through this intricate subject, we have invited a speaker who has spent significant time analyzing the chemicals that often become silent weapons. Please welcome Ms. Rahitya Kasula. Ms. Rahitya is a specialist in criminology and forensic science, holding a master's degree from a prestigious University of Mysore. She built her foundation with a B.Sc in forensic science, chemistry, and genetics from Garden City University, Bangalore. Her expertise is deeply rooted in laboratory fieldwork. She has served as an intern in the chemical division of the State Forensic Science Laboratory, where she gained hands on experience in analyzing chemical substances and preparing detailed lab reports. Beyond the lab, she has seen the ground reality of investigation during her time at the Dhone Urban Police Station, giving her a holistic view of how evidence moves from the crime scene to the chemist's bench. She is also trained in the analysis of biological evidence, including blood, hair, and fiber, making her perspective on toxicology truly comprehensive. Ladies and gentlemen, let us hand over the virtual stage to Ms. Rahitya Kasula. Over to you, ma'am.
Thank you for the introduction, sir. Hello everyone, myself, welcome to the session now. Myself, Rahitya, I'm going to explain you about the forensic toxicology. So, basically, the toxicology is the scientific study of adverse effects of chemical, physical, and biological agents on living organisms. So, how the chemical agent affects the living organisms. The study is called as toxicology, and for forensic toxicology is Matthew of the law. And forensic toxicology, it is an application of toxicology to investigate and solve crimes by identifying and quantifying the drugs, poisons, and their metabolites in the biological organisms. Through the bodily fluids, we can find whether the poison is present in the body or not. Okay, it plays a main role to determine if a substance contributed to a death or incident. It affects on a individuals. Okay, next there are branches of toxicology. First one is clinical, environmental, occupational, analytical, and genetical. So clinical toxicology it deals with the diagnosis and treatment of the poisons. Okay, like antidotes and all come under the clinical toxicology. Next, environmental toxicology. It studies the effects of toxic substances on populations, okay, like the carbon dioxide and the nitrogen gas, etc. Carbon monoxide, global gas. So much is increasing in our like surroundings us. Surrounding us, so much of pollution gas is increasing rather than the pure natural gas. So that pollution, how it affects our body, that comes under the environmental toxicology. Next, occupational toxicology. Here, so so the workers, for example, you can take the drivers when they are traveling. They'll be inhaling so much of polluted gas. That's why they will be having some body issues. I mean, some diseases like body issues. We can say not diseases. So here they'll be having some headache, nausea, etc. And vomiting sensation also. Next, analytical toxicology. This involves the detection and measurement of toxic substances which are present. The basic, so in a simple word, analytical toxicology means it deals with the quantity of a poison present in the poisoned body, like in a body, we can say. Okay. Next, genetic toxicology. It uh, it studies the effects of chemicals on genetic material. Okay, the chemical how when it is injected, how it affects the DNA of the body. It the study of that is called as genetic toxicology. Next, there are some principles for the toxicology. First one is dose response. So dose means the amount of an poison given to a person. Okay, this is what called dose response. Next, um, hazard exposure. Hazard exposure means highly toxics may possess light risk. Okay, there is no exposure. A substance with a low hazard may cause very risk to the person. That is one thing. Next, individual sensitivity. Here, different individuals react differently to the same exposure to a substance. See, if you give a small quantity of poison to a small kid, he will die. He or she will die within like few hours to days, you can say. But if you give that small amount to a larger, bigger person, it won't show any reflection on him because the antibodies and antigens which are present in him, those will be fighting against them, like, and they will protect the body parts and they will be having so much of immunity power, so they are ready to face for the poison for mm, not for exactly all the time, but for a meantime. Okay, that is one individual in sensitivity. Next, route of an exposure. So mainly there are two types of toxicity effects. First is acute, second is chronic. So acute means single result for a single short-term exposure. Like acute means small amount, like small amount for a shorter period of time. Also, it gives more reflection for a body. That means you are eating the most poisonous food. Okay. Chronic toxicity means results from the reported exposure for a longer period. That means you are taking for a small quantity for a longer period of time. When you take a small quantity for a longer period of time, it shows effect. That is called as chronic toxicity. But if you take a small amount for a smaller period of time also, it is acute toxicity. Okay. These are two types of a toxicity. These two are very important for you nutrition also. Next, classification of poison. So the poisons are classified into five types. First one is based on chemical nature. Chemical nature, organic, inorganic, and gaseous. Organic means opium and datura, alcohol, etc. Next, and apple juice also we can say for organic. Inorganic poison, apple juice because apple juice will be having cyanide in it. Not more, but some milligrams it will be there. That's why only our elders also would say don't eat apples too much like that. Next, inorganic poison. Inorganic poisons are acids like sulfuric acids, nitric acid, concentrated HCl, and phosphorus, lead, mercury, etc. Next, gaseous poisons. Gaseous poisons mean like carbon monoxide, carbon dioxide, chlorine, etc. Next, based on the source or its uses. So, pesticides, pharmaceuticals, plant and animal toxins, and synthetic toxins. So, pesticides examples are insecticides, herbicides, and rodenticides, and pharmaceuticals like antidepressants. The antidepressants, when you are in a depression, when you meet a doctor, he will give you. So, when you go to a doctor, there for depression case, there he will give some pills for you. Okay. So the amount of dose which has been given by the doctor, you should use only that amount only. But in case if you take a bunch of pills and you take it and you sleep it, it leads to a poison in our body that causes very dangerous and it may lead to coma also. So that's why only our doctors will say don't use antidepressants much. Okay. Next, plant toxins means which are derived from the plants like castor or animals and plants. So castor plants, those are also poisons. And as usual, snakes are very poisonous. No, that's right. And some more poison, like non-venomous snakes also is there. Okay, those are not having much poisons. Okay, not poison, not much poisons. Okay, next, synthetic toxins. Synthetic toxins are industrial process. While they are see in your nearby your home, so some of the industries will be there. So in those industries, the wastage which is usually those are thrown into the flow water. Those flow water will be filtered and those will be passed to the to our homes also. So if it is not filtered clearly, that it is not chemical clearly, if it is not filtered neatly, then it leads to skin allergies, skin burns, etc. to our body only. It causes many issues. So it causes many issues. This is one type. And drugs also. Next. Based on target or effect. So corrosive poisons cause um, local tissue damage. Like maybe corrosive poisons means it will affect on the skin diseases. Like it may usually affect on the skin. Okay, examples of this strong acids like H2SO4, HNO3, and HCl. Next, neurotoxins. Neurotoxins means it mainly affects our cells. Neurotoxin means it mainly affects our nervous system. So if the nervous system is affected, means central nervous system and spinal nervous system both will be affected. Like cerebral poisons and spinal poisons mainly affects this. Next, cardiovascular poisons. It mainly affects the heart and the circulation of the body. Okay. Next, asphyxiant. Asphyxiant means inability of breathing. So we can say like deficiency of the oxygen in our body also. So here mainly when you breathe the carbon monoxide and cyanide, it like it shows the more effect. Next, organ specific toxins means hypotoxins and nephrotoxins. So hypotoxins means it mainly affects the liver and nephrotoxins means it mainly affects the kidney. Next, based on analytical behavior, volatile poisons and non-volatile poisons, two types of and metallic poisons and miscellaneous poisons are there. So volatile poisons means it can be operated at the room temperature. Here volatile poisons which will operate at the room temperature and non-volatile means under after the chemical process only the mixture or the compound will be evaporated into the gaseous state. So that is the non-volatile poisons. So examples are opium alkaloids and volatile poisons examples are ethyl alcohol. Okay. Next, metallic poisons means these are isolated and identified through chemical test. Okay. Examples for this is arsenic, lead, and mercury. And miscellaneous poisons. Here, a category for the substance that don't fit neatly into other groups. That means it cannot be volatile, it cannot be non-volatile, and even it is not metallic also. So, like that, examples of glass powder. Okay. Next, based on the intent. So, based on the intent, there are three types: homicidal, suicidal, and accidental. Homicidal means intent to kill another person. Okay, so myself intend to kill in your one of your meeting means that is homicidal. Okay, Next, suicidal means killing or harming to myself. Next, accidental means it is an unintentional poisoning. This accidental case mostly happens in the child, okay, like kids, infants. So the infants will not be knowing anything. No, so whatever they see, they'll just keep it in the mouth. Whether it can be poison or not poison, they don't say all those things. So that is the thing. Next, so there are mainly four routes that the poison enters into our body. What are the four means? Inhalation, absorption, ingestion, and injection. So inhalation means breathing. Absorption means through the eyes or through the skin it will be absorbed. Ingestion means when you swallow the poison, that is ingestion, like chewing and swallowing. Next, injection. The poison is directly entered into the bloodstream through a break in the skin. This is the injection. So these are the four main routes, the possible ways to enter the poison into our body. Next, factors affecting the poisons are chemical properties, form, dose, and route of an administration, and age. These all already I explained. Chemical properties means whether it is in concentrated or not. So based on that, the uh, capacity of the poison will be decreased in that. Okay. Next, form. Next, chemical properties. That is chemical properties. Next, form. The physical form of the substance can change its absorption. Added components like binding. So, if you eat curd rice and banana together, it leads to the poison in our body. So, we should not eat both together at a time. Next, dose. I already mentioned the small quantities it may vary, and the large quantities it will be varied. Next, route of an administration is. See, when you inhale, it shows one effect, and when you swallow forcefully, it will give you another type of an result. So, based on the route of an administration, also the effect of an poison is affected. When you inhale for a shorter time, no, it will give like headache and vomiting from it. But when you inhale the poisonous gas like regularly, no, it will lead to the respiratory damage. So this is one thing which affects the route of an administration also, like which affects the poison. Okay. Next, age. Age I already mentioned. For smaller kids, no, it will be like for smaller kids, even if you take in a small quantity, it leads to their death or unconsciousness or coma or anything. But for the bigger people, the smaller toxicity it won't show any type of an effect for them for few days. After the few days, it starts affecting your body. Next, health status. Health status means if the person is healthy, it shows after it takes few days to months, yeah, few days to weeks or months for showing the effect of an poison in a healthy body, in a healthy human being. But if the person is already having any problem in him, then if you give small amount of poison to him also, it leads to some danger, like some danger in the sense like it may lead to is coma unconsciousness and dizziness always like this is next gender. So for females, if you give even small amount of poison also, it lead to like it shows its reflection very in short period of time. But in males, they will be having some of the antibodies more in numbers, so it won't show that effect so easily. Next, duration of frequency. This already I said, no, like chronic and chronic and so chronic toxicity I explained, no, that will show as a cure. Okay, that is the same here. Next, metabolism and excretion. See, if your body immunity is well and trained, so the metabolites will help in killing the poison, and you won't get any like reflection of the poisons, like symptoms of the poisons and anything so easily. Next, nutritional status. So nutritional status means if you eat a healthy food, no, you'll be so strong and it won't let the poison to affect your body that easily. But if you eat continuously junk foods and all, no, it creates it when you eat the junk food much, it creates its own poison in your body. So that's why the nutritional status also. So when you eat more junk food, no, the junk food will help the poison to increase itself and make some cause like harm to our body. That's why we should not eat so much of junk food. Next, some basic like general signs and symptoms of the poisoning. That means, based on these symptoms, we can say that the poison is injected into the human body. What are those general signs? Means confusion, nausea, vomiting, diarrhea, stomach pain, chest pain, dizziness, fits, and loss of an hungry. Next, like weakness or slurred speech, unconsciousness or coma. So these are the basic signs. Based on this, we can say whether the person is injected by the poison, like injected or infected by the poison or not. Next, history. Diagnosis of poison. How you diagnose that the person is infected, like infected by, like affected by the poison or not. So substance identification, like time and duration and route of an exposure and patient details. These are main important patient in the patient details. We want to know whether the patient is having any medical reports or uh, medical problems. We have to mention it. Okay, next clinical means. So in the clinical, I already mentioned no, so clinical symptoms means based on the symptoms, the doctors will say primarily based on the symptoms, the doctors will say so it might be this poison, first take this symptom. So first take this antidote. That's all comes under the clinical symptoms. Okay. Some key symptoms in this are mainly neurological, cardiovascular, respiratory, and gastrointestinal and thermal. Okay. Next, physical examination. So the physical examination means when you see a person, then on the spot you will be explaining whether he or she are affected by the poison or not. So here maybe by observing the papillary response and skin assessment, we can say that. Okay, next laboratory analysis. So laboratory analysis means routine lab tests help assess organ function and severity of the poison. We can say by using the laboratory analysis. So here examples for the laboratory analysis are ECG, liver functional test, and blood gases, etc. Next, toxicological screening. So by doing this toxicological screening, this looks for the presence of drugs or toxins, and it also measures the concentration if anything is present. So here, example is basically this deals with the urine drug screen and blood toxicology screen. And here, advanced techniques are gas chromatography and mass spectrometry. So here, next slide. Here I'm going to explain about the management of an poisoning. First aid for poisoning should be done within the seconds or minutes. So if I'm poisoned, then the first aid for me should be done within seconds or minutes. And if I am alive, like if I'm able to breathe and if my heart is beating and I'm awake, alert, then only you can do the first aid. Otherwise, you should not do any first aid then. because if there's any like hmm, after I'm taking poison, so if poison enters my body after the 1 hour, if I take anything, no, it may the medicine may uh, form into poison and it may cause very more dangerous than the normal poison also. That's why we will not take after this. Next, lab techniques used in toxicology. There are many lab techniques. I'm going to explain you main ranges. Okay. So main chromatography. Chromatography means it separates the complex mixture into the simple like individual components. Okay. In this like stationary phases, the phase should be solid or liquid on its support. Okay. Next mobile phase should be liquid or gas. Common types are GC means star chromatography, HPLC means high profile liquid chromatography, and CCMS means gas chromatography mass spectroscopy. LCMS means liquid chromatography mass spectroscopy. Okay, next spectroscopy. It generally deals with the interaction of matter and electromagnetic radiation to gain information about the structure of the substance. Here, principle is we can say in simple words that it gives complete fingerprint spectrum of the matter based on the specific wavelength, the amount and wavelength it is observed, okay, and emits when it is exposed to the radiation. So, common types of FTIR and Raman spectroscopy. Next, lab technique. So I'm going to explain you about the third lab technique, that is microscope. You all already know the work of the microscope is to show a smaller thing in a large enlarged image. So that is the work of a microscope. Here common types are stereo microscope, electronic microscope, common compound microscope, and etc. Next, spectrophotometry. So spectrophotometry means a method of qualitative and quantitative analysis that measures absorption and transmission of light, specific wavelength to determine the properties and concentration of the substances. So this means the amount of light which has been observed by it and emitted by it, the quality and quantity of light observed by it, it shares. So here examples for those are UV visible photometry, infrared spectrophotometry, and AAS, that is atomic absorption spectrophotometry. Yes, immunoassay. Immunoassay that deals with the binding of an antibody to an antigen. So the bindings will be explained in immunoassay. So here, often drugs or toxins in biological samples. So when the poison enters our body, how it is binding with the bodily fluids, it all deals under the immunoassay. So common types are ELISA and rapid test strips like pregnancy test and some drug test. Some drug test means in athletics, no, when you go for gaming for Olympia, um, nationwide gaming Olympics and all, no? At that time, the every sportsman will undergo drug test. So in that drug test, we have to pass. Otherwise, if we pass in that, like pass in the sense, you should know that the person is not intoxicated. Like he doesn't take any drug or not. We should say. If he is taking any drug, then he is not allowed to the games. So that is what. Next, sample collection for toxicology. Uh, Basically, for toxicology, biological fluids, tissues, hair and nails, and environmental samples, and stomach contents. These are the main evidences that need to be collected for toxicology. Here, sample collection and handling handlers. So, while you are collecting all those evidences, there are some measures to be followed for collecting the evidences. They are like you should use clean containers and labels should be very correctly for each and every evidence. And packaging of the evidence should be neat, and you should maintain the chain of custody and use proper preservatives. For blood, mainly, we use ELBA for not to spoilation, like not to preservative of the blood. Okay, next specific considerations like antemortem versus postmortem. So, like in the postmortem, you should collect the like whether the body is I mean the person is present or not. Based on those also the collection will be changed and the suspected toxins and value also have to be collected. Next, there are many types of poisons like corrosive poisons, acid poisons, alkali poisons, irritant poisons, arsenic, metallic, nephrotoxins, organophosphate, strychnine, nuts vomica, cardiotoxic, Olinder poison, and alcohol and sedatives, drug toxicity, snake venom poison, food poison, and household poisons also. Household poisons sometimes you can take this, like phenyl and all will be there, no? And some those you can take, okay? Next, autopsy findings and poisons. So external findings are food secretions, stains, and skin changes, aroma. Okay, these are the external findings. But when you do the dissection, at the time you can find gastrointestinal tract and organs, specific organ changes like cherry red color discoloration you can find. So if these all are present, kidney damage will be there, liver damage will be there. So if anything of this happens, we can say that the person is injected by the poison. Okay. Next, main crucial for diagnosis is for toxicology, we should have to collect stomach contents, blood, liver, kidney. These have to be collected for sure for the toxicology analysis. Next, history. Detailed history from the police or family about circumstances, treatment, and any he is he is undergoing any medical treatment. We have to know, and any gastric lab reviews is there. We have to know, and several times on vital. Next, so next, these are some antidotes for the poison. Okay, this you can just note down. This is very important for your UGC net exam. This is very important for your UGC net exam. They will just give the poison name and they'll try to find the antidote name. Okay, so this you have to note down. Next, next chain of custody for the toxicology is first is documentation. Sorry, first you have to take sampler integrity. Sorry, it is not in the order. So procedure for cover paper collection, you have to like poison packaging. You have to do the first. Sorry, samples used first. Evidence collection you have to do correctly. Then after evidence collection, you have to cover them like cover properly and collect them in a collection should be proper. Packaging should be proper. Then you have to labeling should be there. Next, after labeling, it should be documented. Documented with the detailed form track sample, origin, name, date, time, and collector and transfer signature also. The respected forensic scientists who are there at the uh, scene of crime, those person have to sign. Okay, that is also should be there in the documentation. Next, transfer protocol. Each transfer between the individuals has to be maintained at very correctly. If there is any any mistake in the maintenance, then it will lead to much legal damage to the person who is responsible for those mistake. Okay. Next, process. So to maintain legal admissibility in court by providing the evidence, authenticity, and reliability for toxicology results. Okay, next, the summary. Here, dose response relationship is very important, and exposure rules and toxic kinetics means where like uh, nephrotoxins and absorption, distribution, metabolism, and excretion are important. Next, testing and evaluation. Here, we in vivo and in vitro studies are happening. Okay, conclusion. So the complete complexity of chemical mixtures and their combined effects and the need to understand how individual susceptibility influences toxic responses, the development and validation of advanced non-animal testing methods such as computational toxicology and organ on a chip models in line with ethical considerations. These are the conclusions. Next, there are two case studies which I'm giving for you. You just read them and you just say me for tomorrow. Tomorrow there will be a Q&A session. No? In the Q&A sessions, you just read this case study and explain me what you understood. Okay, I'll ask any one of you in the class. Next, thank you for your time. I'll just message. Okay, thank you for your time. Bye.